Hello, welcome back to the channel where we develop software for self-driving cars. And we make it available to everyone with a computer because we use Carla Driving Simulator. Here we break the daunting task of autonomous driving into smaller manageable blocks, so you could get into it at your own speed. And you can have some fun by staging things in the simulator like this little trick. Today we're going through some school geometry with Carla Simulator. We playing with positioning of the car in the simulator, but in this case we're just playing with positioning of the camera or spectator. This is useful when you need to test your models and actually see what the car is doing, and by positioning the camera behind the car or the spectator behind the car, you effectively can get them to follow your car so you can see what's going on. So what does it mean to be behind the car? So we know the distance, which is, for example, 10 meters. We want to be behind the car by 10 meters. But what we also do know is the angle of yaw of the car. And that is essentially where the car is positioned by just on the plane of the surface and what sort of direction, north, south, all that kind of stuff. So that is our yaw angle. It's measured as degrees from zero or from north, something like this. So the code we need to use in Carla typically, and you've seen this before in my previous tutorial, is how we calculate camera or spectator angle from a transform of a car or against the car. The way this code works is we apply delta x and delta y to original numbers that we got from the car. So we effectively just need to relatively move the camera back a little bit, but we need to move it in two coordinates, x and y. So that's why we need to figure out the delta x and y. Know that we don't need the absolute coordinates, because for that we'll be using the car coordinates, which is what we need to add to those coordinates or subtract from those coordinates. So it is x, y, z, but we only need x and y. Z is an arbitrary number you can use and just represents how much taller you want to be above the car. It's a delta z as well, but it's an absolute value of your preference. We don't need to calculate it. So to figure out x and y, we need to use school geometry. We have our distance and our yaw angle. X and y are the shorter sides of that 90-degree triangle or right triangle that is very well known in geometry. Because we know just one out of three sides of this triangle, we can't use Pythagoras theorem and just calculate one from the other two. We need to use sine and cosine here, okay? So we're kind of getting in trigonometry, but it's all right, it's very easy. So those things are essentially ratios. Sine is the opposite side to your angle. You take that opposite side and divide by your hypotenuse. And our hypotenuse is our distance to the car. Cosine is very similar, but we take the adjacent side to the angle that we've got measurement of and divide that side by the hypotenuse. Then we just need to rearrange those formulas so we get our formulas to calculate x and y. We essentially need to multiply our hypotenuse by either cosine or sine to get those sides. It's very easy maths from here, okay? The only minor tweak left is just to convert our yaw degrees into radians, because that's when they become ratios that you could use directly, okay? So this is how we get our new function. We essentially pass the distance and the angle to it, and we get x and y deltas back, okay? Let's test it. So we open Jupyter Notebook, and we run some simple code that you've seen a million times to get some imports and connect to the sim. We will test our function today on the spectator. You can similarly connect it to cameras that are not attached to anything and just move that camera with those values that you've calculated. So to test our function today, we spawn a car and send it in autopilot to drive around. And then every time we want to move the simulator window or the spectator towards the car, we use our function. So the way we use it, we get our car's transform values, we grab the yaw angle from those values, which is what we need to pass to our function. And then we pass the distance as well, but it's a constant, so you can choose 10 or 15 or something like that meters to be behind the car, whichever you prefer. And then we calculate our x and y, The only note here is when we use it to apply to our code, we need to subtract it because we want to be behind the car, okay? So we plug it into our code, and then each time we run this particular cell, it just catches up with the car and puts our view just behind, 10 meters behind the car. We also did a little bit of a pitch down, so because we were up high, so we want to look at the car directly, that's why I put the pitch down as well. And essentially, you can also run this as a loop. So for example, you've got a loop that tests your reinforcement model or something like that. So in that loop, you have the car's position. You can run this function every time and then move your spectator or dedicated camera to be positioned exactly in similar spot behind the car or in front of the car every time you want it. And that's how you get the effect of following the car. And the minor difference in the way how you apply this function, whether you want to be behind the car or in front of the car, obviously if you want to be in front, you add delta x and delta y, you don't subtract them. And also you introduce another yaw angle of 180 degrees. Essentially, you just want to turn back the camera to look at the car, all right? And that was it for today. Try this for yourself. This is a good fun. Thanks for your time and see you later.